Hey guys, this is Ed from Mission Ed Possible. Welcome back to my Atari 8-bit assembly language tutorial series. Today we're going to be doing some bug fixing as well as making it so we can get the fifth color on the screen. Let's get into it. So here's where we left off. We have a dungeon and we have monsters, but these monsters are supposed to be able to have 5 colors. You know, we have white, black, red, blue, and then we want to be able to have yellow or gold. Now, if we look at the way we have set up the UI, we actually have all 5 colors. The way we did that is for each of these characters that need to have yellow in them, we add 128 to the number. Adding 128 to the number actually does inverse video. So the way the ASCII table is set up on the Atari 8-bit, only 128 characters are used, and then the other 128 are used for inverse video. So we need to be able to do that programmatically. So here's what we have. We have all these monsters here, but some of them are supposed to have gold. So like this chest, or the mimic actually, is supposed to have gold instead of being blue. All right. Also, the door that's supposed to be right here, this is a doorway at the moment, but the door that's supposed to be there also is supposed to have a yellow doorknob. And if we looked at it, with just a door, it's actually blue. So there's stuff that we have to do for the environment as well as the monsters. So let's get into what we actually have to do for that. So the first thing we need to do is we need to make some alterations as to where on the character set the monsters go. If we look at our dungeon tile set here, we've got all of these characters for the dungeon, and then we've got this empty space here in the middle. And the problem is we have this, the ladder is over on the right-hand side there, and it's really not going to line up for when we're wanting to copy the monsters in there. Copying this data is challenging in and of itself, so keeping things on a nice boundary is better. So first thing I want to do is I want to move this ladder over to the bottom here, and that means one of these tiles needs to go away. My current thought is either the bridge or the one of the tiles that just has the red in it. I think for now, I'm going to pick the bridge. We can always change it later. But so I actually have done that already. Let me go ahead and drop this into graphics. It already exists. We want to replace it. Yes. Okay, so if we look at it now, we have the bridge removed. I think that's the only change that we have in here. So the bridge got removed, and now we have these empty spaces in a nice spot for these. For now, what we're going to have here is we're going to have 12 characters, or 12 tiles that we'll be able to do. So we got 4 up here and then 8 in this bottom row. Now, we also have a B set here. So B, for now, is going to be the same thing as A. But it would be nice to eventually do something where we have animation, like the water or some other animation that we might want to do. It's hard to say right now, but for now, we want to be able to have A and B character sets between the two. And we've already got this set up, so we need to basically, I'm going to just delete this one and then copy and paste this one. And we're going to just name it B. And then we also have the outdoor set. Now, I didn't need to change the outdoor set because it's actually already set up for this. And, we're not going to be copying in monsters because I think we've already established that we're not going to be doing monsters in the overworld. It was just a concession that we had to make. We needed to be able to have in our status line, we needed to be able to have this character set. If for whatever reason we want to change that around, we would need a new character set. And right now, not really wanting to do that. but we do want to be able to have A and B. So I'm actually just going to copy and paste this. The reason why I want to have A and B all the time is because we're going to be switching between these constantly. Now, we may or may not want to have animation in the overworld. Like that would be a good thing maybe for the water. Maybe have these be animated, something like that would be good. So yeah. So we have A and B for the dungeons, the outdoor, and the monsters. The monsters don't actually change. We're all good to go on the monsters. So what we're going to need to do here is we're going to need to switch between A and B, which we already are doing. But the issue is that we need to make it so that when we copy these monsters in, we're going to need to make sure that these also get the A and B treatment. And that's where the crux of the problem lies. And so the deal is that we're going to need to be able to see all of the characters at once. And in order to do that, we should make a map to be able to see all of them at once. The current dungeon layout that it uses is fine, but it takes a long time to see all the monsters and to troubleshoot the problems. So let's create a new map. And I've actually already created one here. And it has 43s around the edge because we needed a border. And if you look at where this is at in here, 43 is this nice square, empty square here, right? So already we have a use for this empty square. Maybe we keep it as empty, who knows? But we've got 43s on the outside, and then we have 0 to 63, which is our full tile set. So 128 characters, but 64 tiles. What we're going to want to do is update our code to use this test map instead of generating one. So instead of this new map and all this stuff and placing the monsters, we're actually going to want to be loading in our other map. So actually what we need to put in here is an ICL at the bottom. I'm just going to put it at the very bottom. Test map.asm. Funny enough, it doesn't look like you actually have to have the .asm extension on there. Okay. And so we're going to be loading that in, and it does load in the map origin. So if we look at our code at the very top, map is going to be loading in at 2000. We're just not going to use our code to generate stuff. So let's go ahead and comment this out. We're also not going to need our monsters. We will need this stuff though. So let's go ahead and add right here. Let's add a thing where we're gonna need to copy this map in. So I'm just going to do an MWA map to map pointer. We've used this before. The big thing here is we want to create pointers for our screen and our map. And we're just going to do a simple copy, nothing crazy. We need to remove this. We want the actual value of this map going into the map pointer. So that's what the pound sign is, the literal or actual value of it, not the address. Okay, so we're going to set the map width to 28, which is what the map is. Counted this out, 28 columns, 28 rows. And so we're redefining this, so we're going to need to actually comment that out up top here. Right here. So we have map width and map height. We'll just comment those out. And we've got that. And now what we need is we also need to choose where we're going to be located on the screen. So the starting position. So I'm going to do 14. And I'm going to store that in player X and player Y. Okay. And theoretically, we should be good to go. So let's try it. Okay. We now see all of our characters on the screen. and they're animated. This is very useful. Something I just noticed. A couple things, actually. One, we can't move around, and we're going to fix that in a second because all these tiles are considered non-walkable tiles. Also, the rat is being moved into slot 43. So if we look, we have rats everywhere. So we don't want that. What we want to do is we want to alter it so that it comes into the new spot, basically where we're standing in the character set. But we can already see all the characters here, which is really what we want. So let's look at the copy monsters function here. Let me go ahead and pull up macros. Copy monsters, and it's setting at 86 times 8. What we actually want is 88 because we're going to want to shift that over. So let's go ahead and run that again. And theoretically, we should have a black background, and we should have the rat moved over 1 square. Okay, cool. That's what we wanted. We still can't move around, though. And that's because all the tiles are considered non-walkable. The only walkable ones are the ones on the bottom. Now, the problem is because we can't move around, we can't see the whole character set at once. So we have to move around just slightly. And that's fine. The issue is, because if we moved over 1, I think we'd be able to see everything but the corners, something like that. But what we want is we want the ability to turn off collision detection so we can walk around anywhere. That's going to make it a lot easier for being able to test. So let's go ahead and do that. So what we're going to do is we're going to turn off clipping. Okay, so for those of you that are old enough to remember the first Doom game, there were a lot of cheat codes, and one of them was no clip, and that was to be able to walk through walls and such. And so it was a cool way to cheat. So what we're going to do is we're going to implement our own no clip kind of cheat code. I'm not going to set it up as an actual cheat code, but who knows, we might eventually want it. It might be kind of neat. So what I'm going to do for that is I'm actually just going to create a variable. It's just going to be able to be on or off. And then what we're going to do is we're going to check in the collision detection, or when we move around, we're going to check for that variable. So let's put it, let's see, in my test code, I have it at C4. So I'll just call it the same thing here. I've already worked out all these things, so that's why I'm going off of another branch. So C4. So I heard a joke. The fact that silly putty exists suggests that there's a serious putty. And then the response is, I think that's called C4. So. Bad joke here. Okay, so we have no clip, and that's going to be, if it's going to be set to 1, then we want to be able to walk through walls and other monsters, etc. If it's set to 0, then we don't want to have that ability. So let's go ahead and set it to 1, and we're going to store it into no clip. We could use MVA, but whatever, it's fine. Now what we need to do is we need to update our move up and move down, all these guys. So we got to do a little tweak to it. So instead of move, what I want to do is I want to change these to be check. So I'm going to do a check up, and that's going to be, we're going to load in no clip, and we're going to see if, basically if it's 0, we're going to go ahead and say move down. We know that, if it's not equal, which means it's going to be set to 1, we're just going to move, actually, sorry, not move down, move up. Otherwise, we're going to say, we're going to look at the up tile, which is right here, compare it. We're doing the, interesting. So I have set in my different iterations, I set this 55 to be a variable. So we can say, I called it walkable start. Where did I set that? Oh, I think I said it in labels. Okay. So I'm not sure exactly where I said it, but that's fine. I'll put it down here. We'll say walkable start equals 55. Okay. And so in here we can say instead of 55, we can just say, compare this, and we can say, let's see, do boom, boom, boom. Oh, that's not the right one. I did Control D, which would do the next iterations of those. I went too far down. One of the things I'd like to do is move things around so that they're in different files. Oh, that's why I did the wrong one. It's fine. So I'm going to say walkable start. I'll do the same thing here. Okay, so we have check up, and we're going to say we're going to load in up tile. Compare it to walkable start. We're actually just going to move these things up. And then the actual move is going to be the decrement right here. So the idea is that we're going to say we're going to check it to see if no clip is set. And then if it's not, that means we're going to do the normal routine, and that is we're going to check to see if it's walkable. Got a bug there. Okay. So we have walkable start, and then we go to done if it is not walkable. And now we say, and maybe a good word would be collidable or something, but walkable works fine. And then if move up, all this stuff is the same for move up. The difference here is that we need to, instead of do move up, we want to do check. So I'm going to just do this, check, up, down, left, right. And we need to do something similar here. So I'm actually just going to copy and paste and change. We're going to say check down. And then what we're going to do is we're going to go ahead and move down. And then we're going to say we're going to load in the down tile. Actually, all three of these can be replacing these three. And then there we go. So now we're going to do the same exact thing. So let's do, let's copy that. Check down, so check left. And then move left. Okay, and one more. Check right. LDA no clip, move right. Check the left tile. Check the right tile. So I'll just remove that from there. That's fine. Kind of did the same thing each time, but slightly different. Okay, so we have check right, check left, move, or yeah. So these are all lining up here. So check up, check, move up, check down, move down, check left, check right, move right. So let's see how that works. We've already set the no clip, so let's go ahead and test this out. Okay, we can move around freely here. So we can see that we have no yellow. We have not dealt with any of the yellow stuff at all, and that's going to be the next thing we're going to deal with. So in order to do the yellow, we need to add some code. So we need to modify our main function that does a blit tile. And let's go ahead and look down for it here, blit tile. So here is the meat of what actually shows up on the screen. And the idea here is when it's storing this screen pointer here, or storing to the screen pointer, we want to check to see if the value should be yellow. If it should, or if the tile should be yellow instead of blue. If the tile should be yellow, what we want to do is add 128 to it. Sounds simple, right? Let's get into actually how we actually do that. We need to modify the Python script that generates the assembly language code. What we need to do is make it so that as well as generating the assembly language, stuff for this, like all the different tiles, we also need to keep track of which one of the characters needs to have yellow versus blue. And so the way I came up with to do this is we're going to use a bit. So each character is going to have one bit associated with it. If it's yellow, it's going to be a 1. If it's blue, it's going to be a 0. 0 is the default. So what we want to do is we want to generate a set of bytes for that. And so let's go ahead and modify the script. So first off, what we want to have is we're going to be building a string, okay, of bits. So I'm going to go ahead and create a string in here called color bits. And we're going to be adding to that color bit, okay? And what we're going to do here is that we are going to see, we're going to say by default, the bit is going to be 0, okay? So we're going to say right here, we're going to say bit equals 0. By default, it's going to be blue. Unless it's yellow, then we need to set it to 1. So we do that down here. Let's see, we have code, okay. What we do is we're going to say if pixels y x equals 1. So the deal is that if we look at the colors here, we have an array set up, blue, yellow, red, white, black, okay? Notice that these are both 1, 1. And so they're for both blue and yellow. So if it's 1, which is right here, that means it's going to be yellow. So we need to say if it equals 1, we're going to set the bit to 1. Okay? And now what we're going to do is after we get through that character, what we're going to do is we're going to check to see if we've got 8 characters. And so we're going to say color bits. Actually, we're going to add the bit to it. And then what we're going to do is we're going to say, we're going to do a mod 8 on it. So we can say if character mod 8, and we actually want, if it's 0, so the way we can do that is we can say if not character mod 8, what we're going to do is we're going to output, let's create a new file. We have output file name. Let's create a colors file name. We're going to do a base name. We're going to add colors to it. Okay. And we're also going to create that file. And we'll use C instead of F. And we also need to do a write on this as well. C write, and we're going to do the same kind of thing as the org, and we're going to call it base name underscore colors. Okay. And so at the top, we're going to have an origin that says this is the base name underscore colors. And down here, we'll say c.write f, and actually we don't really need the Yeah, either way, we can, like, where to put the new line. We can put it here, we can put it up here, either way. I'm just gonna put 2 new lines there, and then, I don't know, it's a little cleaner, I guess. Byte, and we're gonna say color bits, and so that's gonna output color bits to this 1 byte. And then once we're done with that, we're gonna reset the color bits. Okay. So let's go ahead and run that. And I'm gonna run it for the dungeon, because that's the main one we need to worry about at the moment. So I'm gonna go ahead and run this. And we should now have this dungeon character set. Oh, I forgot the new line. Okay, let's fix that. Put that in there. And then, there we go. All right. So we have these 16 bytes set up that represent the 1 if it's a yellow, 0 if it's a blue. Now, if we pull up the character set, and let's go ahead and move this to the right, split right, and I always do that wrong. Okay, and let's go ahead and zoom in. What we can do is we can look at the colors and see if they make sense, okay? Now, so if we look here, this is the first character, second character, third character, and goes all the way up to 0 to 7. And if we look at our stuff here, we actually have 0. So this is, half the line is going to be for 1 byte here. So this is character 1, 2, 3, 4, 5, 6, 7. So, or actually 0, 1, 2, 3, 4, 5, 6, 7. Okay. So this first byte is going to be for the half of the first line. And so if we look here, we do have this yellow dot, and that represents that half of this tile, which is this single character right here. That represents this 1 here. And if we look at the next one, we have the doorknob, which is the 1 here, and the key, which is the 1 here. And if we look at this section of 4 tiles, there's no yellow there, so it's all zeros, and so on and so forth. Now, the issue that we're going to run into here is the fact that there is a situation with most significant bits, okay? Right now, this is going in left to right order. Well, the problem is that we actually need to go in the opposite order, because when we're loading in this data, it's actually going to be the first one is actually the 0th one here, which is the 0th place, and then first place, second place. So this is actually need to be swapped. So that's actually really easy to do. What we can do here is we can say, it's a nice little trick in Python. You just basically invert it. So let's do that again. And we have, now it's reversed, okay? So we now have our 16 bytes in this file. Now we need to load it in. And we need to set aside some memory for that. So we're going to be using the ROM space for that. And let's see. Okay, here's where we want to put it. Okay, so I'm going to create char set dungeon a colors, and we need to go 16 bytes from this AED0. So I'm going to do AEE0. Put that on there, and this is also going to be 16 bytes. For now, we're just going to load in A, and just for dungeon, but we do need to add a spot to load it in here. So I'm going to go ahead and do it right down here. So we say char set dungeon a colors.asm. Okay. So we've loaded it in. We haven't done anything with it yet, but we've loaded it in. And so what we're going to want to do here is we're going to want to add to our tile, our blit tile macro. And we're going to want to basically go through and look to see each bit on here and see if it's a yellow or if it needs to be yellow or not. And then we're going to be adding 128 to it. Okay. What I have done is I've created a new macro here, and I called it fix color. Okay. And what we're trying to do here is we're trying to isolate the bit that we need. And there's a way to do that, and that is to keep shifting it until we move it into the carry flag. And the deal is that we need to know how many bits to shift. You know, for the first character, we don't shift, or we shift 1. For the second character, we shift 2, etc., etc. So we shift all the way over, up to 7 times. Actually, I guess technically 8 times. So we're going to, first of all, we're going to be calling this fix color in our blit tile, and we're going to be sending it the character. So we're going to just go store that in a temp variable, and we're going to copy that. No, I didn't see TAY. It's a very different thing. We're going to say we need the position. So we're using Y in here. So we're going to rely on Y being here as well. So TYA, so we're going to be saying we're going to save the character, and then we're going to be copying in the Y register here into A so we can do stuff to it. So we're actually going to, because we're going to be using Y, we're going to push this onto the stack, okay? And we need Y all the time for dealing with the indirect addressing. So now all this does here is say, hey, whatever's in A, we're going to store it in temp just for temporarily, and then we're going to push Y onto the stack. We can't push Y on directly, so we have to copy it to A, then we need to push that on the stack, and we copy temp back. So now we're in a case where we've saved the Y register. So that's all that really does. So let's see, register. Okay, and now what we're going to do is we're going to AND the, okay, we're going to AND the value in A with 7. Now what that is, if you look at binary, we have 8421, right? And if we have 7, that's going to be 4 plus 2 plus 1. That is the last 3 bits of the number. So we're going to AND it. So we're basically going to mask out the last 3 bits. We need those bits to be able to know how much to shift our character or our color byte. Okay, so we're going to shift it, or we're AND it there. Now we need to add one more to it, AND it with 1, or actually, sorry, we need to add 1 to it. And the reason why is because we need to actually shift it into the carry flag. Because you know, if we're dealing with the last 3 digits, that's only up to 7. What if it's in the last digit? We basically need to use the carry flag as the last thing, because that's what happens when you do a shift, which we're going to be doing here in just a second. We're going to be doing a shift right. And when you do a shift right, the last most significant, or I guess the least significant bit, is going to shift over into the carry flag. So we're going to use LSR to do that. And actually, before we do that, sorry, we're going to need to store this data. Oops, add +1. We're going to say this is how many times we need to shift. So I'm going to go ahead and store that into another temp variable called temp2. Okay. And so what we're going to do is we're going to reload temp again. because we've manipulated it with the ands. Okay, we're reloading temp. That's our character, right? What we're wanting to do is we're wanting to divide by 8. And to divide by 2, we use LSR. So that's going to shift right, logical shift right, logical shift right, logical shift right. That will effectively divide by 8. So what we're trying to do with that is we're trying to get the color index. And that is going to determine which of these bytes that we're going to be working with. And so let's see here. So we have now the byte that we want. So we're going to use TAY to push that into the Y register. And now what we can do is we can load in the pointer at Y. So this is our character colors pointer, and we haven't established that yet, but basically we're going to be creating a pointer that's going to be pointing to this data, okay? And so think of it, pretend we have that already set up. And so this right here is going to get the index. So I can just put here, get color index. So that will say whichever of these we need to get, because we divide by 8 to be able to figure out which of these bytes to load in, okay? All right, so we know how many bits to shift, and we know that we now have in the A register, we have the byte that we're going to be shifting on. So what we're going to do is we're going to create a new section called shift bits. We're going to do an LSR, so that means it's going to do another shift right. And what we want to do is we want to shift as many times as that is in temp2. So actually I go ahead and make a comment here. Get a number of LSRs to perform, okay? How many times to shift? Okay, so we're gonna do an LSR, and what we're gonna do is we're gonna say, we're gonna decrement temp2. Because temp2 is the number, right? And so we're gonna just use that as our counter. And so we're gonna say, if not done, if B and E, we're gonna keep going through and decrementing temp2 until we've shifted enough. Okay? Now what we're gonna do is we're gonna say BCC done. If the carry flag is clear, so if carry clear, branch if carry clear, done. And we're gonna be putting done down here at the bottom. We'll put that in a second. But if we're here, that means that it is a 1 versus a 0. So what we're looking at is in the carry flag. If the carry flag is set to a 1, if it's carry set, then we're going to add the color. If the carry is clear, we are not going to. So that's where this is. So we're going to say load in temp. So this is our character, right? We're going to add 128, which we've been talking about. And we're going to store it back into temp. So that's all it really does, is going through and saying we're going to add 128. So we've added the color, and now we're going to say done. So it's going to get down to here. Now we're going to basically restore the Y register. And we basically undo what we did up here. And so we say PLA, so it's going to pull from the stack, and it's going to pull it into A. We're going to copy that back out to Y. And now we're going to load in temp. And then, stop helping. Okay, and that is, we are done with that fix color macro. Now, what we need to do is we need to add fix color to each of these. So we're going to say fix color here, and we're going to say fix color here. Now, there is a bug that exists right now, and that is the fact that currently we are looking at the character and blitting the left side, and then we add 1 to it and we do the right side. Well, that works great if you're not touching A. I'm touching A all over the place up here. Now, the deal is that that's a problem if you're just assuming that A isn't going to be set, or it's not going to be messed with. Well, we can't just add 1 to it. So what we want to do is we want to load this back in, map pointer Y. We're going to basically reset it back to what it was for the left character, add 1 to that, then we're good to go. And so the blit tile, we don't want to mess with Y because that's being called by blit circle line. It uses Y as well. So we don't want to be touching Y if possible. We do need it, but we don't want to alter it. So we're calling fixed color for the left and the right. So the next thing we need to do is we need to set up this care colors pointer. And so we actually need to do a couple things. One, we need to create a pointer to this data. So in order to be able to use like the indirect addressing and all that stuff, we need a pointer. So let's go ahead and create one. So I'm just going to put it right here. I'm going to go care colors pointer. We're going to put that at C5. And this is a pointer, so it's going to be 16-bit. So we need to set up something that is going to set that pointer. So the reason why we have it set up, there's a couple of reasons why we're going to be doing it as a pointer. Because we're going to have A and B. And so for this care set dungeon A colors, we're going to have the B colors as well. And we need to be able to alternate between them. But for now, what we're going to do is we're just going to set it in here, and we'll clean it up later. But what we're going to do is we're going to do this an MWA of the care set dungeon A colors to the care set colors pointer. What do we call it? What was it? Care colors pointer. Yeah, not care set. Okay. So we need to set up that pointer so that it is pointing to this guy. But eventually we'll switch it around so it does something different. So let's see what happens. With any luck, it'll actually work. Okay, it did not. It decidedly did not. That's interesting looking. All right. Let's see where the bug is here. All right. Well, let's remove monsters for now. I don't think that the monsters are causing this issue, but let's just for fun, let's remove the monsters. Okay. And let's see what it looks like. So we should have blank areas where the monsters are. Interesting. Okay, it really didn't like that. Wow. Okay. Let's try it again. I do know we have a bug in this and that I need to fix it, but I don't think this is the reason for that bug. Okay. I'm wondering if blit tile is happening before this is, and then it's writing to the random data. So let's put this the very start. See if that's the reason. We'll see. Wow. Well, we have different results, but not the right one. Okay. Well, let me first double check my code to make sure that there's not a typo or something. Okay, so the fixed color looks fine. Let me double check on how I'm calling blit tile. Oh, I see a difference here. Okay, we load the tile map, ASL, fixed color. Oh, I forgot that we do a multiply by 2. That, I wasn't expecting to have that result, but let's see what happens when we do that. And maybe that's all it was, but let's see. Not holding my breath. We'll see though. Nope, that was not it. Okay. Well, let's try something simple like turning off animations. I mean, I can definitely pull up the debugger and start working on it on here, but which I might have to. Okay, that wasn't it. All right. Interesting. Well, one of the things that I did do when I was working on this stuff is I did move all of our setup stuff to the beginning of everything. So I set up the screen very first thing. And I also set up all of these things at the very beginning as well. And I'll go ahead and put this in there as well. No. See if that gets us any further here. Okay, it looks better. Okay, so that is something that I did do. So for whatever reason, I think because we're calling things before certain things are set. I don't know exactly at the moment why, but if you notice, we actually have all of our yellow stuff that's supposed to be yellow is yellow. So that actually worked. So we're good there. So now let's copy the monsters in. Altair has been very slow today. Okay, so notice that we actually have a bug here. Notice how it's using the A, B, C, D, E, F, and all that stuff. It has letters. That means that this is using the wrong character set. And you can also see at the bottom there how it has the wrong border. It has the wrong characters that's supposed to be for the border. Now, I did run into this a lot when I was doing testing, and I think basically what it's turning out is it's a race condition, and that has to do with the DLI stuff, the display list interrupts. So, reading online, they're basically, when you're dealing with multiple DLIs, you're going to have a race condition. And so there's a simple way of fixing it, actually. And the deal is this particular area right here where it says LDA, this stuff, it's loading in here and storing it into NMIEN. This right here, we want to have at a specific time. And then what we can do here is, based on the way that the system is set up, it actually is based off the real-time clock. And so there's a nice little trick that you can use that uses the real-time clock and waits for the last digit to change. We use that when we're dealing with the animation as well. It's a good way to use the clock. clock. And so all we have to do for that, to fix that one issue, is to say, I have it above here. So we can say LDA real-time clock 2. That means that's the least significant digit. So it's like milliseconds or whatever. It's not an actual time. It is a certain amount of milliseconds. And we're going to say loop, and we're just going to keep comparing it to real-time clock 2. I think we used a very similar thing for the animation. And BEQ loop. So what that's going to do is it's going to, whatever it's set to, it's going to keep checking to say, is it different? When it is different, that means that one clock cycle has happened, or one of the real-time clock register has gone up one. Then we want to set the NMIN variable for the DLI stuff. So wait until the clock changes to set VBI, DLI stuff. There's probably a very good explanation. I did see on the DLI kind of Bible out there on this is an easy way to do this. DLI stuff can get extremely complicated. What we use is pretty simple, to be honest. But we want something that's deterministic. And by using the clock, we make sure that it'll be deterministic. So we should not have the problem of the wrong character set anymore. So yeah, so worked that time. Let me try one or two more times, but that actually should be fixed. And that was one of the bugs that I was talking about, that it would happen every once in a while. I don't know if you've ran into it before, if you're following along, but it's really frustrating. And it was one thing if it was happening occasionally, and I figured it was just something that, okay, there's some race condition somewhere, but it was happening more often than not. So it was getting really frustrating. Okay, notice that our monsters are not yellow where they should be. That's the next section. But before we do that, I want to turn the animations back on. So I just turn that off here. And the monsters are going to animate, or they should, but it's still not going to be a different color. And that's fine, because we haven't done that yet. Okay, they're animating. Interesting. Our background is animating too. Now that would be really freaky to be walking around and seeing things change, a door changing into a chest and vice versa, or whatever. We don't want that. So let's try to fix these bugs. Okay, so the copy monsters is the main one we're going to start looking at. So that's actually in macros. Let's take a look at copy monsters here. So there is a bug that I noticed I'm going to say is actually in MADS, that I found when debugging, and that had to do with the placement of this end M. And there's this ADBW, which is a macro that I created that is adding a byte to a word. And it had to do with the fact that there was nothing after this skip carry. So I still need to email the author and check the latest, but a lot of the code that I was looking at had the end M actually at the leftmost column as opposed to being indented. So I'm just going to do that. Now, what's interesting is to see if just doing this will change anything. My guess is it will not. I did run into it when I was doing a bunch of work with copy monsters and stuff, but just for fun, let's see if that changed anything. And I did notice it when doing debugging. If you would like to see a session on debugging, let me know in the comments because, nope, it didn't fix it. Because I have been working a lot with the debugger and I don't want to take up all the time in this video on it, but if you want to see a video on covering the debugger, at least as much as I know, let me know. There's one other video out there on the debugger and he covers a lot of stuff, but there's a couple things that I wanted to do that he does not cover. So let me know in the comments. Anyway, so we still have this bug and it's we'll figure out what that is doing. And it's I'm guessing it's in the copy monsters because it wasn't doing it before. So let's look at the way we're copying these monsters. So the idea is that we have a start, a destination, addresses, and then we have the start and end monsters. Okay, and we're going to be putting them in this location right here. The end is the number of monsters. We're going to set it to 12 because it just makes things so much easier. The main thing here is that we're wanting to say, where's the start? So if we look at our monsters here, we have 24 monsters. And if we're starting at 0, and we have 12, that's going to show from the rat all the way up till the mimic, okay? And what we want to be able to do is in each of the levels that get harder and harder, theoretically, the monsters should be getting harder and harder. So a simple way to do that is to have this basically sliding window so that like on the first tier of dungeons, it'll do like 1 through 12 here, and then the next level down, maybe 2 through 13, and keep going down to where maybe at the bottom level, you're going to get to, some of the higher end monsters. The idea here is these monsters are supposedly stronger monsters. The weaker monsters are down here, rat, zombie, these kind of things that are really simple. And then going to like the gazer, vampire, wyvern, ogre, stuff like that. So these guys are meant to be harder monsters. So the easiest way to do it is to shift things around. So we want to say we're going to start at a certain monster level and then go 12 monsters after that. I have some comments here. Just we can I'll go ahead and copy them in. So characters, let's go ahead and copy and paste them. Okay, so we say the characters are 8 bytes wide, the tiles are 2 bytes wide, and in the, tiles are 2 characters wide, actually. In the dungeon/outdoor character set, there's an open section starting at character 88. So that's where this is right here. Okay, so we're copying these into temp outer 1 and temp outer 2. And so we're going to add to temp outer 2 so that we are starting at the spot that we want to start at. Okay. And so what we're going to do here is that we're going to do the same with the monsters. The monsters could start at 0, but we want to also be able to start up to 16 because 16, it would be, so if we look at 12 monsters, we're going to be into the dragons here. But the deal is that if we don't, we want to be able to show the beholders. The gazer. We want to be able to show these guys if we don't have a dragon. So we want to be able to go up to 16. Now, there's an issue with that, and that is we need to multiply by 16 in order to have this work. Well, the problem with that is 16 times 16 is 256. It's one more than what a register will hold. The idea is it goes from 0 to 255. Well, if you try to set it to 256, that's going to be 0, and it's going to wrap around, and we do not want that. So what we want to do here is we want to say, we're going to check to see if it's 16. Okay, and we're going to go ahead and I'm going to make a new thing called shift, new label, and we're going to compare it with 16. And if it's 16, we want to be able to just go down, or rather, if it's not 16, we want to shift it. If it is, what we're going to do is we're just going to add 16 to it. Okay, temp adder 1, 256. So we're adding 256 to temp adder 1, and we're going to jump to done. And then, if not, we're going to shift 4 times. Shift left 4 times is multiplied by 2 times 2 times 2 times 2, so it's 16 times. And then we're going to store that into temp, and then we're going to add BW, and this is probably where I ran into that bug. Temp adder 1 temp. So it's going to add this many characters to the monsters. So we have a pointer that starts out at the 0th character, and we want to be able to go up to the 16th character as our starting monster. So that's what we're doing here. So we're just making it so our starting point is at the first monster. And we've already done that with the dungeon. Now we need to just, or the characters that we're going to be inserting these monsters into. So now what we need to do is, so we've done all the inserting that we need to do. We need to have a done label. And so now what we're going to do is we're going to do the copying. Okay, so we're going to use the Y register and need to set it to 0. And we're going to loop through. We're going to increase Y, and we're going to, now what we're going to do is we're always going to do 12. And this is where it's kind of nice. If we wanted to do something with a certain amount of monsters, and we need to say what's the end and what's the, all these things, if we have a variable end, that's kind of a pain because especially when you're dealing with numbers that can get over 256 or 255, and that's one of the issues that I was running into. So what we want to do is we want to say it's going to be 12 regardless. So that is 192. So that's going to be 12 times 8 times 8, I believe, or 12 times 8, 12 times 16, I believe is 192. And we're going to compare it with 192. And if not, we're going to say we're done, or we're going to keep looping. Okay. Now let's see here. We don't need end anymore. Okay. We only need the start, the destination, and the starting monster. Okay. The source rather, and destination starting monster. So let's go back to main. And then what we can do is we can say in this copy monsters bit, we don't need 12 at the end. And we're going to say 0. And we're going to want this to also be a variable. And one of the things that I ran into is when I was trying to make these a variable versus making them a literal, that this only works in testing. If we're going to be wanting to say for this level, we need to have this number, we need it to be able to be a variable. So let's go ahead and start, or let's go ahead and create a variable here called starting monster, staring monster, that'd be a funny monster. Okay, C3, and we're also going to want to say number of monsters, which we're going to set to a certain value here of C2. And we could actually put that as a hard-coded thing, but for now, we're okay there. So now we say the number of monsters is at C2. Now we need to set these variables. So we do want to use the number of monsters when we're actually placing the monsters, and that's where this place monsters is. But for now, what we're going to do is we're going to say we're going to MVA, and we're going to be putting in a number to be able to say the starting number. Okay, starting monster rather. And then when we call this in the copy monsters here, we want to say starting monster instead of 0. Because we want it to be variable. Okay, let's see how this goes. Hopefully it fixed our weird overcopying thing. It's possible that it doesn't. We'll see. Yep, okay. Well, they are animated, they are copied. The deal is, though, we're starting off with 0, right? But for whatever reason, we're not starting with the 0th because this is the skeleton. And if we look over here at the monster here, monsters A, this skeleton is actually the 3rd skeleton over here, or rather the 3rd tile. So we have a bug. Let's take a look at what I might have messed up. Okay, so we have a bug that I have not encountered yet. Why are those animating that way? Let's take a look at, let's first of all, let's try turning off animation to see if that's what the deal is, okay? See if that's the problem. I mean, obviously it's a problem. I think I might know what the problem is now. So we turned off animation. The issue is that, I know exactly what the problem is. It's not code. What the problem is that we generated this B, but we didn't regenerate this. So I need to call my other script. And I apologize if you're screaming at the screen with the answer. Definitely if you were, comment down below. Man, how far back was this? Okay. If you knew what the problem was, definitely leave a comment. Okay, let's try this again here. Let's go ahead and turn animation back on. So the clue was the fact that it was fine with one, but not with the other. So let's go ahead and run it. So we need to compile it and run it. We still had an issue with the copy monsters. So we'll take a look at that. Why it's starting on the wrong one. Okay, so our background isn't changing. And our colors aren't there yet, which we haven't implemented that yet. Oh, another thing to consider is that the edges are cut off because of our flashlight thing. Eventually, I'd like to have something to where it just shows everything. But for now, it's like that. So that's why the ladder was not being shown. Okay, so we have an issue with the starting number. It's not correct. And I think I know what the problem is with that. Oh, here it is. So this, and I dealt with this a bit. That right there is taking the address of versus rather the, we want it to be the literal 0 value. And that's an issue here in that we're wanting to load in, when we say $, we're saying the literal versus the memory address. So that's the issue here. So let's try this again. Yeah, that was a typo. Something I had in previous iterations. Okay. And now we're starting with the zombie. That's good. And we end up with the ogre. So that's correct because we set it to 1 and we end up with the ogre. So let's try our different edge cases here. That's not really what I wanted. That's okay. Let's change it back to 0. Yep. Okay, starting with the rat and going to the mimic. We can actually leave this up. Well, it's a pain for one screen. Typically when I have two screens, so I usually set up my editor on one screen and Altiera on another. So let's set it to 16. See if it gets there. We don't need to take it into account if it's more than 16, because we're just going to say that's going to be a hard-coded limit, and that's okay. We want to be able to show that the setting it to 16 will work as well. All right, so we start off with the scorpion and we go to the two dragons here. Okay, it's kind of cool seeing the dragons animate now. We hadn't seen them before. So we start off with the scorpion and we go to right here. So that's actually working just fine. Now that we have the monsters copying in, now we need to copy their colors. And this is where it gets a little tricky in that we can't just say copy this whole byte over to here and copy this byte over to there. Because of the way we have things laid out, that's just not going to work. Because if we look, this is if we're copying a whole byte, that's going to be 4 tiles at a time, right? Well, the problem is that we can start a bit off each time. And actually it's 2 bits off each time. And so we have this thing where we want to copy part of this byte and part of this byte into this one section. And then if we start with a different number, we need to do a different section. And it's really, I actually worked on the math on this and it's complicated to be able to do. So what I ended up doing for this, and if you have a all-in code solution for this, definitely let me know. But the way I ended up doing this is I implemented lookup tables. It does take a little bit more space, but it's better. And so I actually updated the Python script to handle monsters being a different type of output data. So let's take a look at that. First off, what I want to do is I want to add a argument to this to say if it's a monsters thing. Add argument, and we're going to say -- monsters. And we're going to say save, was it say store true or something? Let me look at my code. Action, we're going to say action store true. So if we set this flag, then we're going to have a monsters variable set. So what we can do down here is that if it's a monsters, we don't want to do this. So we're going to say and not args monsters. And then at the end, what we're going to want to do is we're going to want to do something a little different. And I'm just going to go ahead and copy and paste this in. It's a bit of code here. Let me walk through it. So we say if the argument, if monsters is enabled, what we're going to do is we're going to go through the possibility of 0 to 16. That's why we have a 17 to cover the last case. We set j to I times 2 because we need to keep track of I every time. And you don't want to have to, we need to go up by 2 every time. So that's why I'm doing it that way. And then I create a byte list here. So this is the first byte is going to be it's going to start at j and then go to j plus 8 and then j plus 8 to j16, j plus 16, etc. What that's doing is that it's trying to say we're going to start at wherever I is like. So if I is 0, we're going to take those 3 bytes like that we talked about looking at here. If I is 0, it's going to take these 3 bytes. If I is 1, it's going to take these bytes and then a little bit more of the next, and so on and so forth. So that's what this is doing. It just keeps shifting it over. And so for each entry, we're going to have 3 entries. So we have a possibility of having 17. 17 times 3 is 51, I believe. So it's adding these bytes to this array, and then it outputs them when it's done. And it does do the reverse thing. I don't want to forget that. So let's go ahead and do that for, let's see, Python. So we have one for A, one for B, and let's take a look at these. So now notice we have, it's quite a bit longer in that it's 51 bytes in here, but we have a lookup table that if it starts with 0, it shows these 3, 1, it does these 3, etc., etc. Again, if you have a better way to do this, let me know. This takes up 51 bytes, and it's going to multiply by 2 because we have monsters A and B. So the code to do this is pretty extensive, though. For now, I'm using this lookup table, and it works. So let's go back into main here. And actually what we want to do is we want to create a new macro called copy monster colors. So let me go ahead and do that. Now the good thing is, because we're using the lookup table, it's pretty small. The code. Actually, before we get there, let's allocate the memory and load it in. So we got to do that first. I think I put it right here. Let me look at what we got. So let me go ahead and add the rest of these. So we have Dungeon A, Dungeon B, which we don't deal with. Now, the deal is that we do have colors for both A and B. We could get away with just having one, but the problem with that is if you have anything that you want to animate and change colors in the other one, so like let's say you wanted to go from blue to yellow and back and forth, you couldn't if you don't do it this way. Now, almost all of these would be just fine. There's only one exception that I found, and that is the monsters. This owlbear, or this owl creature, he has a yellow nose. Well, if you look at the Dungeon or Monsters B, he turns his head to the left, okay? And what's funny about that is the left-hand side is normally blue, but because of this, it would be yellow because we said the default is going to be blue. So what would happen is his nose would change from yellow to blue every time he turned his head. So I decided, you know what? We may not need it, but let's put it in there, and we could always remove it later if we don't end up using it. So I'm going to go through and set it up for the dungeon as well as the outdoor set and as well as the monsters. So let's go ahead and do that. So the outdoor A, outdoor B. We're not using outdoor just yet, but that's okay. So we need to keep adding more to these. So we're going to go to AF00, AF10. So these are all 16 bytes each. And then now we're going to add monsters, A colors. Probably should have used care set in there, but it's okay. So AF20 is where it starts. This one uses 51 bytes. And doing some math here. I'm not going to actually do the math here, but it comes out to be like that. AF53 is another 51 bytes from the AF20. Okay, so we now have space for all these allocated. We can only go up to B000 though with what we have. So we're getting down there on the amount of space we have. That's going to be something we're going to have to possibly deal with. And it may be something that the colors, we might have to make concessions on it. For now, I'm just doing it. It's fine. So I'm going to go ahead and load these in. Now, we also are only loading in A for the outdoor set. We don't have, we do have a B here, but it's just a copy of A. So I'm going to go ahead and put that in there. I think we have memory allocated for it. But let's look here. Yep, we have the memory allocated for it. We're just not using it yet. So let's go ahead and load it in. So we'll just put this here, A and B. And we're going to do char set dungeon A colors, B colors, outdoor colors, and monster colors. And we're going to need to run the script for all those. We don't want to forget that. So these are just called monsters A colors, monsters B colors. Okay, and so let's go ahead and run these. So I did it for A and B. So now I need to do for char set dungeon B. I think we already did that one, but that's okay. We'll do outdoor A and outdoor B. And so now we have the assembly for all of these as well as the colors. Okay, and they're identical. They're not going to animate yet, but we could easily add some animation to it and it'll just work. So let's go into our macros and actually do the color for the monsters. So we have, okay, so this one's not too bad. So we're going to create a new macro. And we're going to call it copy monster colors. Okay, and we're going to have a source, and we're going to have destination and the start. It's going to be very similar to the copy monsters. We're going to use a pointer here, just like we've done before. Temp adder 1. Okay. And the first thing we need to do is we need to get into our, we need to look up the index on our monster colors. And one of the things that we notice here is that we have 3 bytes per monster, or per character, I guess, per starting number here. And so the deal is that we need to multiply by 3 in order to get to the correct number. So if we go here and we say, we're gonna take the starting number, and we're going to, so in order to multiply by 3, what we do is we can't type, we multiply it by 2 and add the number back. So to look at this is let's say if we're adding, if we're multiplying by 3 and we're let's say we're dealing with 0. 0 is going to multiply by 2, it's still 0, and add the number, is still 0. 1, you're going to multiply it by 2, it's going to be 2, and you add the 1 back, it's going to be 3. That's right. 2 should be 6, right? So 2, you multiply it by 2, and it's going to be 4. And then you add the number back, and it equals 6. So this works. So we're going to say ASL, and then we're going to add the number back. And we're going to store that into Y. Now what we're going to do is we're going to load in the temp adder 1, Y. And this is going to be where, I hate when the editor does that. We're going to be loading in at the correct index, because we've multiplied it by 3 to get to the right index, because we have the starting number, So 0 is 0, 1 is 3, 2 is 6, etc. And so we're going to be loading in at the start right here, or right here, or right here, etc. And what we're going to do is we're going to want to get the first byte, the second byte, and the third byte. And so what we're going to do here is we're going to say that, and we're going to store it into, we're actually not going to even need this line here because we're not going to use that temp address. We're going to do something a little different here, and that is that we're going to store it in the destination at that particular address. So we know where it is going to be in our pointer or our colors. And if we can look at, say, like this is our standard one, right? We know that if we looked at this guy here, we're going to start right here. Well, this correlates with byte 11, 12, and 13. So that's where these guys are 0, right? Well, this is going to be, byte 11, 12, and 13. Now, that was why we wanted to shift everything a little bit, because otherwise it'd be a real pain. So all we're going to do here, I keep them all over the place here. All we're wanting to do is we're going to say we're going to store this first value in the destination address plus 11, then plus 12, and then plus 13. And this seemed to be the best way to deal with this. And the reason why we're doing it this way, as opposed to our typical of using the indirect addressing mode here, is that we're doing something different than just going up by 3. We are going up by here, and we would have to add the 3. We'd have to add that number to our destination address, and that's just kind of annoying. We know that it's going to be wherever it is plus 11, then we're going to do plus 12, then we're going to do plus 13. So we're going to do this actually just 3 times. Could we do in a loop? Yeah, but it gets a little hairy, as I was saying. So, we could use another, we'd use X or something, but this is all we need to do. So we're going to store it in 11, take the next byte, store it in 12, and take the next byte, store it in 13. We've already done all the pre-calculations needed to be able to say, this is the starting address, this is what the bytes we need to copy in this way. Doing all that pre-work and putting it in a lookup table was so much easier than trying to do it in assembly. I spent quite a while doing it that way. Again, if you have a better way of doing this, leave me a comment. But we now have copy monster colors. We just need to call it now. So up here, in our start of our program, we're going to say, right here where we say copy monsters, we're going to say copy monster colors, monsters A, and we're going to be copying them into the color pointer. So we have, actually we have a current colors. Do we still have that yet? We need to set aside some RAM to be able to copy our dungeon tile set into RAM and then copy our monsters into that. We can't do that with ROM. So we're going to set up some free space here. So we need to put our colors in here. So let's put it right here. Let's put it as cur care colors A. And we're going to put it at 7380 cur care colors B. And so this is going to be 16 bytes. And this one is going to be at 7390. This is also 16 bytes. Okay, we have a little bit of space here and a little bit of space here. Totally fine. So now we have these guys set up. Now we're going to need to copy those. We have our current character colors. We need to copy the dungeon stuff into that. So we're going to do copy bytes And we're going to say character set dungeon A colors into cur care colors A. And we have 16. So this is a macro we already set up before to be able to just copy bytes. B goes into B. And so now we've copied our bytes in there. Now instead of, let's see, so our monsters we copy. Now what we need to do is we need to copy our monster colors into there as well. So cur care colors A. And we also need to know a starting monster. So starting monster. And let's do the same for B. And yeah, so we have now set it up so that our monsters get copied, our monsters get copied, our monster colors get copied. The last thing we need to do is we need to switch between A and B. And the way we're going to do that is we're going to set up a pointer to look at the current colors. So what we do is we're going to set up this pointer at C5, which we actually already are doing. So let's see where we're using that. We did this here already. So we actually need to do this functionality here. We need to do this in a macro because we're going to need to be switching back and forth. So let's go ahead and set up a macro to do our switching. Macro set colors. That's what I called it. There's setup colors and there's set colors. Probably could think of a better name, but we're going to load in the character set A. Now what this is just a Boolean effectively. It's 1 byte, but it's just there to say, are we using A or are we using B? And so we can switch the pointers accordingly. So we're going to say use char set B. And if that's the case, so we're going to say MWA cur care colors A. We actually should name that A. We're saying use character set A. We're going to say char colors pointer. Otherwise, what we're going to do is we're say BEQ use char set A, and then we're going to do MWA cur char colors B, char colors pointer, and then we're going to jump to done. Okay. So here is, we need to put a done in here and end M. So let's say when we've set the character set A, let's just do it here, because then we don't have to do it every frame. Let's see, undeclared macro copy bytes. I guess I had written that macro recently and it's been a while. So let me go ahead and look for that macro. It's very simple. Copy bytes, source destination number bytes. This is the same stuff that we've been doing for a long time in that we're starting on y equals 0. We're just going from y to whatever the number of bytes are, load it in from one spot, save it to another. Pretty simple. So let's see how this runs. Okay. Interesting. Looks like it crashed or stopped moving. Interesting. Huh. We definitely have some weirdness going on. Oh, well, we don't need this anymore. Not that that should matter. because that's going to be handled with our set colors macro. But just taking a look here, we've got A going into A, B going into B, A going to A, B going to B, A, B, A, B. Okay. That all looks correct. Well, that's a problem. We don't want to be copying monsters A and monsters B. We want to be copying the monster colors. Okay, let's try that. That's better. It helps if you're copying the right data. Okay. We now have colors and animations for the monsters. And when I mean colors, I mean actual good colors, not the bad colors. So now let's remove our temp map stuff, put this stuff back. I'm going to go ahead and just copy, or I'm going to comment out this stuff because we're not going to need that. I'll go ahead and leave clipping off and put back the map width, map height, and we don't need this anymore. Let's try that out. Okay. So one of the things I notice right now, and I know why, is this should be the up ladder right here, not the down ladder. Notice if you go to the outside thing here, it's very, very easy for you to go out of bounds. We know about that. That's because we're flipping the bit. Once you go, minus zero, when you go to 0 and you go left, it's going to assume you went to, or it's going to change to 255. So we don't want to do that. But okay, so we have our monsters looking good. We have a chest in the place of a door. That's the same issue as this over here. What's interesting though is the chest is alternating colors. Odd. And we're showing dragon pieces and a blank square. Okay, I think I know what all of these problems are. Let's take a look at them. So let's go back in here to main. We're going to look at place monsters. Okay, place monsters. We say, okay, we're going to have, it's 255 monsters, but it's going to say we're going to have 12 monsters. Well, we actually do have a number of monsters set here that we probably want to use. So let's go ahead and say MVA 12 num monsters. To have 12 monsters. And actually, if we're going to start here, let's do 8 monsters because then we don't want to have to deal with the dragon stuff right now. So I'm going to just put num monsters. Let's see if that helps. Should help not show dragons at least. Let's see how this looks. Okay, so we don't see any dragon pieces anymore. We do see this, the blank square, and yeah, but everything else looks pretty good. We don't see the dragon pieces, okay? Let's look at place monsters. Okay, so this right here is the problem. It's at 43 instead of 44. So remember, 43 is this location, and that's going to give us the squares the blank squares. Okay, so by changing that to 44, we should be good to go for that. Okay, let's try that. Okay. Not seeing any more squares. That's good. No more squares. Our doors are still messed up. We'll take a look at that. So at this point, we have our doors that are messed up, and we have a dragon piece here. I think this is supposed to be our down ladder. Okay, so what it is these labels. Okay, so what we need to do is look at what the maps are, map labels here. So we have up and down. So we know that this one, we have the numbers here set up. Okay, so this was 120 and was up. Down was 119, which is over here. So we need to shift these. So we're going to say 121 and 120. And then this also needs to shift. There's the door. Now this is the map door, but that should actually be this one here, right? So that actually, let's look at the labels. There's door, but then there's also doorway. So that's the open door, right? But the door is actually going to be at 4 right here. 0, 1, 2, 3, 4. Okay. So let's try this out. Okay, we now have an up ladder. And let's look at the door. Okay. We have the proper door. Now we have no clipping, so we can just walk through the door. That'll make testing a lot easier. Eventually, we'll have to open that door. We'll do that logic in another video. But yeah, so we now have all the monsters. They're animating. They're the right color. And we can actually just walk through the map. Let's go make sure that down one is good. Yep, we are good to go. So what'd you think? A lot of stuff today. This video took a lot to make happen. And if you enjoyed it, be sure to hit the like button. And if you'd like to see more of these kind of videos, be sure to hit the subscribe button. Usually the videos are not this long, but there was a lot of little things that needed to be done, and a lot of the logic was non-trivial. So it took quite a bit of work. And the good thing is, though, that we should be smooth sailing from here. We'll be able to add some really cool features soon. So stay tuned for the next episodes where we're going to be doing just that. I've been working on this series for quite a while now. And if you want to see more of this series, go up here. If you want to see something else, go ahead and click up here. As always, see you in the next adventure. Take care.